This video is part of my complete practical CCNA course where I explain CCNA topics using physical devices and practical examples. Now, you've probably heard of ChatGPT, but have you heard of hallucinations and seen examples of hallucinations with AI or artificial intelligence? AI is now part of the CCNA course, but I want to show you some of the advantages and disadvantages of AI. And here's a very simple example of hallucinations. And I'll start with Midjourney. Let's ask it to create a YouTube thumbnail without an elephant. Keyword, without an elephant. I don't know if you agree, but that's not a YouTube thumbnail without an elephant. It's thumbnails that have elephants front and center. Okay, let's try another one. So imagine create a YouTube thumbnail showing a living room without an elephant. While we're waiting for that to complete, this is a good example of AIs hallucinating. AIs will confidently tell you the truth and just as confidently give you totally false information. What about this? Here's the results of our thumbnails of a living room without an elephant. And again, I don't know if you agree, but the elephants in these pictures are front and center. So these are definitely not living rooms without elephants. So that's Midjourney not doing such a good job. A lot of you may be thinking, okay, but what about ChatGPT? So let's start with, I really like elephants. And then we told that elephants are amazing creatures and some other information. But now I'm going to tell it to generate an image of a living room without an elephant. So image is being generated. I don't know if you agree, once again, that's a living room that has an elephant in it. And we told here is the image of a cozy and modern living room without an elephant. Don't know about you, but it's very easy to spot that elephant in the living room. I hope you like the design. If you have any other requests or need more images, feel free to ask. Let's ask it to generate another image of a living room without an elephant. Don't know about you, but I can easily spot an elephant in this living room. Notice right over there. And we're told that this is another stylish and elegant living room without an elephant. This is a good example, once again, of an artificial intelligence hallucinating, confidently telling you totally incorrect information. So I've shown you two examples, Midjourney as well as ChatGPT. So once again, hallucinations are where AI confidently gives you incorrect information. In our example, we told it to draw a room without an elephant as an example. It hallucinated and said, here's an image of a cozy and modern living room without an elephant. This image is based on tutorials from Cisco U. They have free tutorials that help you understand AI for CCNA, as well as a bunch of other free content. I'm really happy to say that this video is sponsored by Cisco, and you get free access to the best written content to help you prepare for the Cisco CCNA AI section of the CCNA exam. Don't go and take your exam without having a look at this Cisco tutorial, Understanding AI and LLMs as a Network Engineer. Again, this is a free tutorial on Cisco U to help you prepare for your CCNA exam. So make sure that you go through my video, but also make sure that you read this tutorial and understand the contents of this tutorial before you go and take your exam. So they cover topics such as supervised learning, unsupervised learning, reinforcement learning, and all the other topics that you need to know for the CCNA exam, including predictive and generative AI. So notice here, they're talking about predictive AI, generative AI GPTs. They also discuss hallucinations and RAGs. RAGs is a topic that you may struggle with. There's a whole section here discussing what RAGs are and how they make AIs more accurate. The CCNA exam is not focused just on pure AI. We're looking at Cisco AI Ops in network operations, and there's a section showing you the products that have AI built into them. So make sure, once again, that you go through the Cisco tutorial. I've linked it below. It's free. All you have to do is register on Cisco U, and you can get access to this content. Fantastic to see that Cisco are making more content freely available, and I'm really happy that they're sponsoring my channel, allowing me to create more free content to help you change your life. Make sure that you go through my video, but also go through the Cisco U tutorial on AI to help you prepare for your exam. I'll link that as part of this video. So once again, here is an example of DALL-E or ChatGPT creating a living room with an elephant in it, even though we told it to create one without an elephant. Don't always believe what AIs tell you. A lot of results could be totally incorrect. Often depends on the training data, depends on how the AI is configured. Hallucinations are a real problem with AIs. So in networking, we obviously don't want hallucinations. So you need to know this concept of Retrieval, Augmented Generation, or RAG, which reduces hallucinations as well as out-of-date information. So it's not just that the AI is giving you incorrect information, it may be out-of-date information. Basically what you do here is you combine the capabilities of a retrieval system and generative mode. In this case, we are basing the AI on specific data, not just the internet, which could have false and true information. So as an example, at what layers of the TCP model are routers? The answer is routers operate at the internet layer of the TCP IP model. In other words, layer 3. A prompt is sent to a retrieval system based on a knowledge source with context. And that prompt and context through the RAG gives you the correct answer. When you start learning about machine learning or AI, it gets really confusing with all the terms. I found that this is a very good way to understand it. And when I first learned, I found that this was my aha moment, if you like, or this is where the light bulb went on. In a few minutes' time, this will hopefully also make sense to you. In traditional coding or programming, what we do typically is we have if-then statements. We run code based on data. So as an example, very basic program. If it's raining, then take an umbrella. Otherwise, take a hat. That is an example of a very basic program. Here's another example, and I want to give credit to Coursera, Introduction to TensorFlow. If you really want to get into this in more detail, have a look at that course. Fantastic course. But for the CCNA, you don't need that level of knowledge. So another very simple example of coding. If the ball strikes a brick, the brick is removed. So if ball collide brick, remove brick. And then we do something with the direction of the ball. So it bounces off the brick as an example. But if we miss the ball and it goes off screen, we lose a life. Again, very basic program. In this kind of traditional programming, we have rules which are set in our programming language. If this, then do this. We also have data, which could be variables or databases or something. So we've got data, and then we're applying rules to the data. So the input is rules as well as data. We have our traditional programming, and then we get answers. Data could be, it's raining. Rule could be, if it's raining, then take umbrella. Simple programming. With machine learning, however, we change the paradigm or way of thinking. It's a totally new way of thinking here. Rather than rules and data, we have answers and data, and rules come out. So notice we have swapped our rules and we have swapped our answers. So rather than creating the rules, we are allowing the machine to create the rules based on the answers and data that we give it. This becomes really useful when data isn't clear-cut. As an example, how would you code this example? We want to determine what someone is doing. So as an example, are they walking? We might code it based on if the speed is less than 4 miles an hour. They're running if the speed is greater than 4. They are cycling if the speed is greater than 12. But what happens if they're golfing or doing some other kind of activity? How would we run pattern recognition on that kind of data? So it becomes very difficult at times to write code for pattern recognition because there might be so many variations. What happens in the real world is not always consistent. As an example, different people walk at different speeds. Different people run at different speeds. Different people cycle at different speeds. And what about all the other activities, such as golfing, etc.? Not easy to write code for every permutation or every example of an activity. So with machine learning, once again, we change the paradigm. Here we get lots and lots of data. So we get lots of examples, and then we add labels to the data to indicate what the data is. So we are adding labels so that the machine knows this is a dog, this is a cat, this is walking, this is running, this is cycling, etc., etc. So we've got lots of data, and that's something very important to know. With machine learning, big requirement is the more data, the better the machine learning is going to be. More and more data is better. And that's why you'll often see that companies that implement AI are sucking up data all over the place. ChatGPT, as an example, trying to get data from the full internet. The more data, the better the machine learning algorithm. So rather than trying to code this, with activity recognition, we are telling the machine that this is walking. We are telling the machine that this is running. Notice the label is running. We are telling it that this is biking or cycling. We are telling it that this is golfing. We are telling the machine what activity the data contains. And then we are allowing the machine to determine the answer. So again, notice the difference. Answers and data in, rules out. We are providing labeled data, and then the machine determines the rules to recognize, is it a dog? Is it a cat? What is it actually saying? Now, before we go any further, let me show you a practical example of machine learning where you can program an AI without any code. So Google have this teachable machine which allows you to train a computer to recognize your images, sounds, and poses. It's a fast, easy way to create machine learning models for your sites, apps, and more. No expertise or coding is required here. So this is fantastic. So as an example, you can get it trained on images, sounds, and poses. Now that's nice, but let me show you practically how to train a computer. So let's create two classes here. Let's make it simple, cats and dogs. I'm going to upload images. So rather than using my camera, I'm just going to upload some images. So I'll just grab a few images here. And as you can see, various images of cats like leopards, lions, and domesticated cats are now uploaded. Let's upload images of dogs. So I've got a few images of dogs here. So I'll grab a few of them and upload those. So here we've got two classes of images. Now, for an AI to function well, it needs lots of data. I've only given it a little bit of data. We've also added labels to the data. So the AI knows that these are cats and these are dogs because I've correctly classified the data. So we've given the AI the answers. We've given the AI data. Now, through machine learning, rules will be created and we'll be able to test those rules. So let's train the AI. And there you go. As simple as that, we've been able to train the AI. Now it's showing an error because it can't access my webcam. I don't want it to access my webcam. I'm going to upload a different image. And let's see if it classifies it properly. So I'll upload this image. It tells me that there's a 65% probability that this is a dog, 35% that it's a cat. So got that right. Let's upload another image. Let's take this one. 100% that's a dog. Upload another image. Let's try this one. Okay, 89% that's a dog. Let's try some cats. Now, these images are not part of the original data, but notice it correctly classified that as a cat. Take another image. This one here. That's 92% a cat. So got that right. 100% that's a cat. Okay, but now let's trick it. So I'm going to give it data that it hasn't seen before. In this case, a horse. Now, the training data is only done on cats and dogs, and now I've given it a curveball, something that's neither of those. So it can only choose one of those two based on the data that it's been fed. And this is the issue with machine learning or artificial intelligence. You need to make sure that the data that's fed to it is the correct data, that it's learning on a large data set, a large amount of data, and that the data is actually correct. Okay, let's try a zebra. Thinks that's a cat. And another horse, 68% a cat, 32% probability that that is a dog. This software is fantastic, however. And notice you can download JS code if you want to put this into a browser. You can download a TensorFlow version if you want to use this as part of Python. And they also have a TensorFlow Lite model, which works on mobile or edge TPUs. So without having to code anything, we have been able to create an AI that can recognize images. Now, obviously, I could create another data class here. Let's add horses and let's upload some images. I'll only upload 2 images. Let's see if we can pick up the third one. Let's train the model now. So here's an example where the data set is probably too small. It still determines that this is a cat rather than a horse or dog. And that's probably because I used the wrong image here. I used a donkey and one image of a horse rather than more pictures of horses. So again, you need to have good data to train your AI. This is again a paradigm shift from traditional programming. In traditional programming, we create rules like if it's raining, take an umbrella. If it's not raining, the sun is out, take a hat. We have data and we write rules for that data. So traditional programming gives us the answers. Here we have the answers and the data, and the machine learns the rules. Very different paradigm to traditional programming. Now let's talk about AI specifically for the CCNA exam. This is found in 6.4 of the CCNA exam, version 1.1 blueprint. Notice this section, 6.0, is 10% of the exam and includes other topics such as automation and programmability, controller-based software-defined architectures, etc. But the section we're going to focus on in this video is explaining AI or artificial intelligence, both generative and predictive. Notice those two. You need to know the difference, as well as machine learning in network operations. Notice this term. Cisco are focusing specifically on AI in network operations, not just general AI. Now, in a lot of AI discussions, you'll see they mention something called an artificial neural network, based on the concept of a neural network in the brain. So with AI, we are looking at human intelligence simulated by computer systems, where there's learning, reasoning, and self-correction. I just need to make an important point about the differences in AI, and then I'll come back to this about Cisco-specific AI implementations. There are different types of AI. One of them is artificial narrow intelligence. We actually use a lot of this today. An example would be a smart speaker or self-driving car. This is not general intelligence. This is AI for a specific use case. Very useful when applied to something specifically. Another example that I like is detection of viruses. So in antivirus systems, they are using AI to detect anomalies, detect software that isn't acting normally. The hype these days, if you like, is around Gen AI or generative artificial intelligence. We've got examples like Claude, we've got ChatGPT, we've got Midjourney, many examples of this out there, and I've shown you some of these already. The one that a lot of people are concerned about is artificial general intelligence, or AGI. This is where AI can do anything that a human can do, and here you've seen many movies over the years. The Terminator series has been an example of this, where the machines take over. A lot of people are worried about this, but generally most development has been on ANI and generative AI. A lot of the experts don't think we'll see AGI for many, many years. Lots of hype out there about this, but generally artificial intelligence is applied on narrow domains rather than replacing human beings. But like all things in life, we shall see. Experts have been wrong in the past. We shall see what happens. Now, from a Cisco point of view, we have used Python, Ansible, Terraform, other technologies like that to configure network devices for many years. When coding those systems, you have to explicitly code what you want the automation tool to do. So as an example, if you code a Python script to configure VLANs on a switch, you have to have the data of VLANs to configure. So you might have that in a text file. You have the Python script pass that data and then SSH to a switch and then configure the VLANs. Very explicit instructions of what the script should do. So this can save time because you're having a machine configure network devices and many network devices, but you are programming the machine what to do. Remember, what we're doing is providing rules. We're providing data. So as an example, we may have a list of VLANs. Let's say VLAN 1 to 100 need to be configured. So we store that in an Excel spreadsheet or CSV file or something. So we're providing the data, and then the rules are, if that VLAN doesn't exist, create the VLAN and then configure this VLAN on this specific port or whatever. So we are programming the rules and the data, and then the result is answers. Let's say a pass or fail with that configuration. We have also updated the configuration of the switch using our Python script as an example. So rules are set in our programming language. If the VLAN isn't there, create the VLAN. Perhaps you want to delete other VLANs. So you might want to pass the configuration of the switch, and only certain configurations are allowed on specific interfaces. And then you test that against a variable or database that you've created. However, as explained, not all situations, and network challenges included, can be addressed with static configuration. We might need something to dynamically determine what is done in a network. We'll need the AI to identify patterns, looking for anomalies, and then make changes based on what it sees. Example that's often come up, and I've interviewed people at Cisco about this before, is the Cisco firewalls. You can statically configure, and we've done this for years, firewall rules on firewalls. The problem is you can't always anticipate what's going to happen. You can't think about all the traffic patterns out there. It's also very difficult to keep those firewall rules up to date. It's also very difficult if people change jobs and we have hundreds or thousands of firewall rules. Would it not be nicer if the AI suggested firewall rules based on the traffic that it sees? Or when you interface with an AI, that you use a generative AI interface, so something like ChatGPT. So you interact with the AI rather than hard coding AI rules, which can be very difficult to understand. You are asking it questions about the rules and then analyzing the rules through a chat interface. Cybersecurity is a good example of where you want dynamic configuration based on anomalies. You don't want to just look at static traffic or static configuration where you've thought of every possible situation, because it's unlikely that you've done that. Think again about antivirus software where anomalies of behavior are looked at to stop viruses. So as an example, again, to teach antivirus, we can provide data. So good software, bad software. Show it examples of malicious code. Tell it what's good software, and then it can create the rules to determine, is a new piece of software malicious or is it good? Now, machines can learn in three primary ways. First way is supervised learning. That's what I've actually already demonstrated, where you as a human help the machine learn. As an example, we told the machine that these were pictures of dogs, these were pictures of cats. The second option is unsupervised learning, where the machine learns by itself. Doesn't need to be taught by a human. And then we've got reinforcement learning. So three options where a machine learns by trial and error, basically learns from its mistakes. So let's look at each of those in more detail. So in supervised learning, once again, the AI is trained using labeled data sets. So if you remember, as I discussed before, rather than having rules and data and then getting answers, what we do here is we provide answers with the data and the machine learns the rules. So we told the machine, this is a dog. We told the machine, this is a cat. Now, in this example, which is more relevant to networking, we may classify some applications as safe and some applications as malicious, or traffic flows as safe and malicious. So we're helping the machine by giving it classified data, in other words, labels on the data, and it can then learn the rules to determine when it sees something new, what is good and what is bad. So again, with supervised learning, this is a method where the AI is trained using labeled data sets. We can use supervised machine learning to characterize network traffic or predict security threats by telling the machine what is safe or malicious traffic. The AI systems can learn from the labeled data and can identify patterns and relationships between the different types of network activities. This process involves feeding the algorithm both the data needed to analyze, so the inputs and the expected outputs to teach it what to look for. Now, going a bit deeper, in supervised learning, we have classification and regression algorithms. So both regression and classification algorithms are supervised learning algorithms. Both these algorithms are used for prediction in machine learning and work with labeled data sets. The main difference between regression and classification algorithms is that regression algorithms are used to predict continuous values, such as price, salary, age, and so forth. Classification algorithms, on the other hand, are used to predict or classify discrete values, such as male or female, true or false, spam or not spam. Now, unsupervised learning is different to supervised learning in that it does not rely on labeled data sets. We basically allow the AI to uncover patterns or groupings by itself. So this obviously has a lot of potential in that we don't have to pre-classify the data. We just let the machine discover stuff itself. So we give it a bunch of data. Machine looks, as an example, for anomalies in the data. So again, with unsupervised learning, we are not relying on pre-labeled data. Rather than doing that, the algorithm is given the freedom to work through the data itself or sift through the data and uncover patterns or groupings by itself without human intervention. This is really useful, once again, in networking for looking for anomalies. So looking for traffic that's malicious, as an example. So we have our normal traffic on our network. Let's look for anomalies or differences to the normal traffic to identify someone hacking the network or a worm working its way through the network. So it allows the AI, once again, to look for unusual traffic patterns that deviate from what's considered normal or from your baseline, potentially flagging a security breach without prior knowledge of what to look for. Now, going a bit deeper into unsupervised learning, we have dimensionality reduction, clustering, association rules, and the one that we're most concerned with is anomaly detection. So again, what is unsupervised learning? It's a type of machine learning that learns from data without human supervision. Unlike supervised learning, Unsupervised machine learning models are given unlabeled data and allowed to discover patterns and insights without any explicit guidance or instruction. Now, you may not know this, but unsupervised learning is actually used a lot in our daily lives. They're used to help power personalized recommendations, real-time translations, or even automatically generate text, images, and other types of content. So where is this most powerful? It's best suited for more complex processing tasks, such as organizing large data sets into clusters. They are useful for identifying previously undetected patterns in data and can help identify features useful for characterizing data. As an example, think about the weather. Huge amount of data. Allow the machine to look for the patterns rather than us as humans trying to label the data for the machine. So in this example here, a machine learning model is clustering similar data points and then can create groups of clusters with natural demarcations. So with clustering, we are exploring raw, unlabeled data and breaking it down into groups or clusters based on what is similar or what is different in the data. Examples here would include customer segmentation, fraud detection, image analysis. The machine is basically splitting the data into natural groups by finding similar structures or patterns in the data. Now, some more examples of unsupervised learning is anomaly detection, where unsupervised clustering can process large data sets and discover data points that are not typical in the data set. Again, from a security point of view, let's look for traffic that deviates from our normal traffic. Recommendation engines are another place where this is used. Customer segmentation, as mentioned, is another place. Fraud detection as well, and natural language processing. Now, for the CCNA, I wouldn't worry too much about the details of these, but make sure that you understand the difference between supervised learning and unsupervised learning. Now, the third way of learning is reinforcement learning. In this example, AI systems will learn from the results of their actions. It's kind of like the trial and error learning method. So the machine does something. Was it a success? Yes or no? The result comes back, and the machine can learn from the results of its actions. So machine learning is a dynamic learning process where the AI systems learn from the consequences of their actions. You do this, you get this result. Learn from that. In the context of network operations, this means that the system can refine network performance by adjusting configurations and policies in response to real-time feedback, aiming to achieve optimal performance. This basically allows network systems to dynamically adapt to network conditions, change their configurations based on what's happening on the network. The goal here is to optimize the configurations and optimize network operations. Now, something you really have to know for the CCNA exam is the two types of AI. We've got predictive and generative AI. With predictive, we're looking at vast data sets and then predicting something. So look at this curve, predicting something. Generative AI is probably what most of us are familiar with, like draw an iMac, and then something is generated like this. You may have used ChatGPT to create all kinds of things. So as an example, write a hello world function in Python. And there you go, it's created that hello world function in Python. I could simply copy that code and use it. Whether that code is good or not depends. Again, be careful of hallucinations. Be careful of badly written code. Let's create another one. So create an OSPF configuration for a Cisco router. And notice ChatGPT tells us a bit about OSPF, explains the example scenario, and then tells us how to do it. And scrolling down, notice it's building the code for us. So tells us to type enable, then conft, set the host name of the router. Okay, that's got nothing to do with OSPF, but there you go. It's configuring OSPF with process ID 1, enabling it on different interfaces, and then exiting the configuration and telling us about the configuration. Now, what's interesting with ChatGPT is notice I asked it previously to create something similar. And here, the output was very, very different to what it did this time around. It's generating configs on the fly. Output may be different. What you get with ChatGPT may be very different to what I'm getting. But now let's talk about predictive AI. Here we analyze historical data to forecast future outcomes. This relies on machine learning algorithms to identify patterns and trends within vast data sets. So again, the machine is looking at current data and then is predicting what's going to happen. So again, predictive AI is where artificial intelligence analyzes historical data to forecast future outcomes. It relies on the AI identifying patterns and trends within the data, enabling it to make educated predictions about what's going to happen in the future. Now, the important part is in the context of network engineering, predictive AI can enhance network performance, reliability, and security by anticipating problems before they arise and allowing for proactive management. This is always the issue with network management. We know when there's a problem, but can't we predict a problem? And this is where predictive AI is very useful. Why didn't we look at indicators to tell us before the network melts? So look at increase in utilization on interfaces, look at other parameters, and see indicators of a problem in the network rather than waiting for the network to break and then being told the network is down. So again, this can help us predict equipment failures, network performance issues, to help us be proactive in network maintenance and network performance optimization. Look for issues in the network like network congestion as an example. Now with generative or Gen AI, we are going beyond prediction to create novel insights employing sophisticated machine learning models such as generative adversarial networks or GANs and transformer models. So as an example, we tell the AI to draw a switch and there we go. So let's ask ChatGPT to generate an image of a network switch. And there you go. That kind of looks like a network switch. It's got some interesting ports over here. Don't know what's going on over here, but there is kind of a switch. So it's created a new type of switch. Generate another image. Let's see what it does. Okay, now it tells us it can't do it. Let's try that, telling us what we should do. Let's just take exactly what it's asked us to do, and let's tell it to create the image that it's just told us the prompt for. And there you go. This, according to ChatGPT, is that kind of switch. But what you'll notice is it's creating brand new images. Let's do one more. Generate a network switch icon that can be used in network topology diagrams. And there you go. That's not too bad, actually. Gives us a good idea of what a switch would look like, perhaps. Not too bad. Now, the thing about Gen AI is it can create a wide array of outputs. Could be text, could be images, could be code. I've shown you an example of code. What about music? There's controversy around AIs like this one, but Suno allows me to create music. So I've created quite a few of these, but let's create a new one. Create a song about Cisco CCNA. And then I simply click create. And notice it's created something called Network Dreams. I've done quite a lot of these already, but let's play this one.
Cables on the floor, router switch galore, packets flying high, data in the sky.
So you can see on the right hand side here, it's got the verses. Not great. Maybe you like this, maybe you don't.
Subnets left and right, configs every night.
Okay, let's try another one.
Cables on the floor, router switch galore.
Interesting that it's saying routers rather than routers. Must be a British singer. Let's try one that I created a long time ago. So Network Dreams here.
Cables running through my veins, routing every pulse and strain. IP addresses flashing light, chasing data through the night. Plugins clicking tethered tight.
That's another example of Gen AI, in this case, creating a song or multiple songs about the CCNA exam. Now, a particular kind of generative AI is called Generative Pre-trained Transformer, or GPT, hence ChatGPT. This has obviously become very popular thanks to its advanced language processing capabilities. And I've just shown you a few examples of this. I showed you how to generate images, how to create code, and even music. So many options available with Gen AI GPTs. Now you can use generative AI in network operations. It can simulate network scenarios by creating realistic network traffic patterns, which allows you to test and evaluate network performance under various conditions without affecting a live network. It can also automatically create optimal network configurations based on current demands and predictive insights. It also helps in developing potential solutions for network issues, providing multiple options for optimization and remediation. So Gen AI and Predictive AI are often used together in network operations. Predictive AI can identify and anticipate problems in the network, while Gen AI creates simulations and solutions to address those issues proactively. So by combining the strengths of both those two AIs, network administrators can make sure that their networks are more resilient and more dynamic. In other words, run better than we could without AI. Now, big worries when it comes to AIs is firstly privacy, confidential data being sent to the internet and stored in public AIs, and security. You don't want to post passwords or security tokens on a public AI. It's very worrying these days how companies are often sucking up our data and using that to train their AIs. Famous example that's touched me personally include Microsoft Recall and Slack using all the personal data within Slack to train their AIs. Be careful what you put in a public and even a private AI system. So again, we need to be careful about security and privacy, particularly when the information is shared through public instances of GPTs like ChatGPT are accessible to anyone without any specific security or privacy guarantees. Only use public GPTs, like ChatGPT being the most famous one, for non-confidential inquiries, general inquiries, such as asking about coding practices, troubleshooting generic software issues, or understanding technology concepts, and also use it for learning and experimentation. So explore AI capabilities and generate non-sensitive content through the public AIs, but don't use it for sensitive data. Never input or discuss any personal, financial, or operational data. Don't put your API keys in ChatGPT or your passwords or any information that could compromise security. Also avoid discussing details about your internal IT processes, security setups, or architectures that could provide a blueprint for potential hackers to attack your systems. Now, private GPT instances are tailored for restricted use with enhanced security features. They can handle more sensitive queries under controlled access conditions. However, be careful about confidentiality. Don't expose highly sensitive information to a private GPT. It's possible that through misconfiguration, data could be leaked or security flaws could exist and someone could access that information. Think about data control and monitoring. Ensure that all data shared with GPTs is monitored and controlled. Anonymize your data. Use data masking to help avoid direct exposure of sensitive data. Lots of hackers have proven that they can circumvent the guardrails in ChatGPT and get it, for instance, to create malicious code. There are GPTs out there that have no guardrails, so it's possible for attackers to generate code that's malicious without anyone stopping them. Attackers can even use your AIs and your chatbots against you. So they could use an injection attack on a chatbot. Famous example, once again, is where someone got a chatbot to sell him a car for $1 rather than talking to a salesman. So people can circumvent the controls on chatbots and AIs to get them to do all kinds of things. As an example, you may have a chatbot that helps you create automation code, but someone could use a injection attack to prompt it to write a script that erases the entire operating system of a Windows computer or a Linux computer. So it's important with AIs to make sure that they don't accidentally share confidential information, and you need to implement security to not allow anyone access to your private GPT. Big issue these days with GPTs. I've interviewed various security professionals, and at the moment it feels like AIs are a bit of a Wild West.
Yeah, it sounds like a bit of a Wild West, right? It is Wild West.
Lots of exposure of data, lots of issues when it comes to security with regards to GPTs.